Hello. Sorry, we're having some technical difficulties. I hope you can uh, hear me, see me, and we're gonna wait for a few people to join. Hi, sorry, we're having technical difficulties. We have to recreate a new link, so give us a couple of minutes and we'll get back on it. It's over there, see? See. Hey guys, we're experiencing some technical difficulties. I think it's only 2 people logged in at this point. We're gonna wait for more people to log in. Give them 5 minutes. Sorry about this. I hope you can hear me now. Okay. All right, then I guess, can you see me? Okay, you can see me, you can hear me. Let's see, let's wait for more people to join. Let's give them 5 minutes. We're sorry about this. But for the ones that are here, the overview of what we're gonna do is these are things you need. We're gonna go over the things you need to be careful about, explain a bit about the offset feature, and then we're gonna do some testing. If you have any questions, please feel free to put them in the chat. If you can ask the questions whenever you have the question, or if you want to wait until the end of the presentation, we'll also have a Q&A session for it. Yeah. So let's continue. Things you'll need. So what we will be looking at today is the PAL-HIKAri has an offset feature. And this offset feature can come in handy for a few things. The first is if you have two Hikaris side by side. So let's say you have a Hikari in that field and you have another Hikari in that field. And when you bring them together, they're not reading exactly the same, even though they're reading the same fruit. So you put the same fruit on one Hikari and you put the other on the other Hikari, and they're slightly different. You can change the offset feature so that both Hikaris are reading the same. So no matter where you take them, you know they're taking the same reading. The other reason for using an offset feature is when you want to compare the Hikari to the traditional digital refractometer. So just to be clear, the Hikari is not meant to replace the digital refractometer. The digital handheld refractometer is still the most accurate handheld way of reading bricks. But if they're reading slightly different from each other, you can bring the Hikari to read closer to the PAL-1 or PAL-2 or palette that you might have. We have two distributors that have compared the Hikari to a RX, and they read comparable as well. So today we're going to be looking at the user scale specifically. In the past, I have done one for the Hikari series for kiwi, and I think Taylor has done for other fruits. So you can go back and look at those videos if you need to. Today, we're only talking about the user scale. So things you need. If you're going to be creating a user scale, you are going to need a type of refractometer. Hopefully it's a digital refractometer because you need something to compare it with. You're also going to need at least 3 fruits or 3 of the same types of fruits. The more, the better. The more data you have, the more accurate your user scale will be. And you're going to need filters. Filters, well, we have these types of filters. It's not paper filters, because paper filters will not work. They'll get soaked and it's not going to work. You need some type of fiber filter that can filter out the pulp, but not the juice. Okay. So those are basic things you need. Obviously, you also need knife or some type of cutting instrument to cut the fruit. Okay. Things you need to look out for is the fruit temperature and the instrument temperature. The fruit and the instrument need to be around the same temperature. So acclimatization of the fruit and the instrument is very important. Keep them at the same temperature so that when they're reading, it reads accurate. Because if you're taking the fruit out of the fridge or out of the freezer and the instrument is somewhere room temperature, then that difference in temperature is going to give you a slightly different reading. Not just because the Hikari has a narrower ATC, but because the fruit's consistency at different temperature changes. If it's colder, if it's warmer, the consistency of the pulp of the juice inside the fruit changes, and Hikari is going to pick up on that and is going to read differently. So make sure that the fruit and the instrument are at the same temperature, and be aware of the accuracy. As I mentioned before, PAL-1 is 0.2 accuracy, has 0.2 accuracy. PAL-3 has 0.1 accuracy, and Hikari, they vary depending on model, but this one, for the cherry that we're going to do today, it's 1.5 Brix accuracy. Okay. The offset feature. A lot of our other models have different offsets than this. For the Brix, PAL-Brix salt, PAL-Brix acid is slightly different. The offset on the Hikari is very easy. It's just like a plus or minus a number. So it can go down to minus 9.9, or it can go up to plus 9.9. So that's the range. Okay. And something that came up in the previous presentation was, do you place the fruit on the Hikari, or do you slightly press it down? We're going to do both today to see the difference. Normally, because of the design, you have the light going into the fruit and then the fruit glowing or bouncing off that light, and you have the sensor. When you press it, normally the Brix is a little higher than when you place it. So if you place it, it has a Brix, and if you press it down, because the fruit comes closer to the sensor, it should have a slightly higher Brix. We're going to see the difference because, like I said the last time, there is no wrong way of doing it. You can place it or you can press it, as long as you always do it. So if you choose to place it, make sure you always place it and you don't press it. If you choose to press it, make sure you always press it. Okay. Any questions? We're good? All right. So let me erase this part so it doesn't distract you. And we will start with cherries. We'll start with cherries, and then we're going to move on to kiwis. So give me a second. So as you can see here, we have two different types of cherries. I'm not sure which type this is. Or actually, I'm not sure which type this is. But we have two different types of cherries. I don't think this is Rainier. We'll have to find out. But anyways, you have the PAL-HIKAri. Okay, it doesn't need zero setting. Brix is 12 to 26. Cherries normally have a little higher Brix than 12. So NNN is because there's nothing placed on it. Just a quick review of the instrument. This ring here is where the light comes out of. And the center point is where the light sensor is. This metal plated ring is for temperature. So the idea is that this cushion, let me see, this cushion is supposed to block this light from going directly to the sensor. So this light is supposed to go, all of it is supposed to go into the fruit, and this cushion is supposed to block it out so that the only light that this sensor receives is coming from the fruit. Okay, so if this cushion is not if it's not pressed well enough, then this light can go in here and you'll get a different Brix. Yeah, and then this hood is supposed to protect the light from external light. Sorry, protect the instrument from external light. Okay. So first of all, what we do is you have to remember we said about being careful about the temperature of the fruit. We want to wear gloves so that your hand is not also changing the temperature of the fruit. So maybe now the instrument and the cherries have the same temperature, but if I'm start grabbing the cherries or keeping it in my hand, then I change the temperature. So normally you wear gloves, and for the positioning, I also take off the stem just so it's easier to position on the Hikari. Okay, so for the first reading, we have, let me just test it out, make sure we have good repeatability. If you don't have good repeatability, then you want to change it. So for example, let me do something like this. Okay, that for sure is a bad position because you see that it's having a lot of external light. Okay, so you want to position it that way, and then check the repeatability. And if it's repeatable, then that's a good position for you. If you take it off and you put it on, it's repeatable. Sorry, slightly different here. Okay, so the first reading is 16.7. So we're gonna do one side first, 3 different readings of one side, and then we're gonna turn it around. So let's slightly change the position to get, okay, now we have 17.0. Slightly change the position again, 16.4. Okay, and we're writing down this on the table. Later I'll show you the results. All right, so that's placing the fruit on one side. Now let's start by pressing the fruit. I'm gonna take 3 readings. 16.3, it didn't change much. 17.1. 16.5. So very, very close. The other thing you want to check if your instrument is being affected by outside light is you can cover it. So let's say here, let's read it, 16.5. If I cover it and it reads differently, see? So it was being affected by external light. So this is one way that you can check if it's being affected or not. Okay. So it's not being affected that much. So we're going to leave it as is. So now we're going to turn the side and we're going to measure the other side. Okay, just by placing it. Check repeatability. All right, we got 18.9 on the other side. Let's change the position. Oh, too much. 18.8. 19.3. All right, then we're going to do again, and we're going to press it down. 18.8. It's not changing much, which is good. Different fruits will react differently. For example, with kiwi, it's going to change. With cherry, it seems it doesn't change. 19.3. And 18.8. All right. So if you have a calculator, keep it handy if you have a cell phone, or because we're gonna take the average. Okay. So now we took the bricks reading of this side and this side. So what we're gonna do is this instrument, this PAL-3 is already a 0 set. Okay. So we're not gonna 0 set. It's already ready to go. Okay. So what we're gonna do is we are going to cut this side of the cherry that the instrument read. Then we're gonna put it in to our filter. Then we're gonna squeeze the juice out of it. Okay, and this one that we're measuring right now is side 2. So this is the bricks for side 2. And it's 17.9 bricks. Okay, now let's clean that up. And then we're gonna cut the other side. We're gonna measure it. Give me a second. I think I misplaced my filters. There we go. All right. So let's put it in the filter bag. Let's squeeze as much juice as we can out of it, because if you leave some in the fruit, it's not representative of the whole part that the Hikari just read. Okay. Now the bricks of the side 1 is 17.6. Okay. Now let me show you the table, how it looks so far. So this is the table so far. This is when we placed it, when we pressed it, and this is the PAL-1, PAL-3 reading. So with the traditional refractometer, it read 17.6. As an average, it looks like the Hikari was reading 1 bricks lower. So remember, the accuracy of, sorry, let me go on this side. The accuracy of this model specifically, which is the one for cherry, is plus minus 1.5. Okay. And then the accuracy of the PAL-3 is plus minus 0.1. So we're looking at a total accuracy of, oh, sorry. Nah, okay. So the accuracy of the Hikari is 1.5. The accuracy of PAL-1 is 0.1. So the total accuracy combination of this comparison that we're doing is 1.6. Okay. So for side 1, the Hikari in general was reading 1 brick lower, which is still within accuracy. It's very good. But we can adjust that. And for side 2, it was reading, depending if you're placing it, oh, yeah, it was reading about 1 brick lower as well. So think if we change, if we offset, remember the offset range for the instrument is from negative 9.9 to positive 9.9. So I think if we change the Hikari, you can adjust the Hikari to see to bring it closer to what you want to read. Something that also affects this cherry is the colors. Right now I can't show you the colors, but side 2 was red and side 1 was yellow. Okay, so that's where these changes might be coming from. So let's test out the other cherry. We're going to erase this data and just test this cherry, which is more homogeneous in color. All right. So let's clean this up. So for the results that we just got, we saw that on one side, the Hikari was reading 1 brick higher, and the other side, it was reading 1 brick lower, still within the accuracy of the range. So for that one, I wouldn't be recommending an offset because it's right in the middle. If you offset to one side, then you're gonna make the other side worse. So for that example, or for that type of cherries or situation, then no offset. I wouldn't recommend an offset. But let's check this type of cherry. Okay, so same thing. Oh wait, this is slightly damaged. Let's look for a new one. Yeah, so sometimes you're going to run into situations like we just did, where the instrument is reading the best it can on both sides and no offset is needed. All right, let's check this cherry. This is a sweeter cherry. Let's look at repeatability. Okay, good. All right, so side 1 is 20. Give me a second. Let me see if it's getting external. No. Okay. Side 1 is 23.3. First one. Then 21.9. $23.5. Okay, that's one side. The other side. Oh, sorry, you're not. Never mind. We gotta do this side again, and we're gonna do pressing to see if it has a difference. 23.1. And we're not gonna press too hard because we don't wanna juice out the cherry. 22.5. 25.0. Okay. Now the other side is 24.5. 24.0, 24.2. Okay. And if we press it, 24.9, 23.3, 23.6. Okay. So now, don't forget the sides. Which side's which? We're going to cut out side 2 first. Then we're going to juice it. Remember, try to squeeze the most juice out of it because the Hikari read that whole piece. Okay, so for side 2, it read 24.6 bricks. So it's pretty good. Let's read the other side, side 1. So for you guys that join in later, and we're gonna put this information on an Excel, and we're gonna share it with you so you can have it as a reference and a clear explanation of how we calculated accuracy and how for the first cherry, this type of cherries, we don't recommend an offset. It didn't need it, but we're gonna see what happens to this one. So remember that the filters that you want to use are the fiber. They're not like paper, because even if it gets soaked, it doesn't let through any pulp. So the bricks is 24.8. Okay. So for this one, there might be a slight adjustment that we can make. Very slight. Let me show you the table. All right, that's the table. So with the refractometer, it read 24.8. With the Hikari, read 22.9 or 23.5. So the Hikari was reading just a little bit lower in bricks than a refractometer. For this side, side 2, it was reading, if you were just placing it, it was reading right about the same. Or if you compare it by pressing, there's reading slightly lower. So for this, I would recommend, if you want to do the pressing, you see you get the same results, more or less. And you can put it up a little, just a little, and if you're going to do by placing, then you can also put it up a little. But you can just change it by 0.5 or something, and then bring it a little closer. But for this as well, there wasn't much, you didn't need much change as well within the accuracy of both instruments. So yeah, good examples here. One last thing I want to cover is the how you would prepare samples for. We're not going to write anything on the board anymore. Is how you would prepare samples for bigger fruits. For example, we have a kiwi. Okay, how would you read a kiwi, or a mango, for example? Okay, so for that example, similar to cherry, we have two sides, and you would do circles just so you don't get lost. Name it side 1, side 2, okay, and you would put it on like that. Take the reading, just like we did earlier. We would take multiple readings, slightly different positions, just to make sure it's, it's around 14.2.5. That's good. Then measure the other side. Oh, I read a little different. Let's see why. Okay. It's 13.9. Yep. So I read 13.9 to 14.0. So more or less the same on both sides, which is good. Now, sample preparation for this is a little different. Okay. You have your two circles, cut them in half. Okay. And then you need to cut out the circle that your Hikari read. Oops, cuts didn't go through. All right. And that's the circle that you need to juice out and then read on a PAL. Same thing with this. You would cut out the circle, and then that's the part that you need to juice out. So you wouldn't juice the whole half because the Hikari didn't read the whole half. It just read this part here, and it didn't read it all the way to the other side. So the Hikari read here, and it didn't read all the way, okay? So that's why you need to cut it in half to divide it, and then cut the circle just to get the bricks of the part that you need. You juice this, and you place it on a PAL-1. Any questions? No? Okay. We'll send you this data later. Thank you for joining, and I'm sorry for the technical difficulties in the beginning. Some people couldn't see us, some people couldn't hear us. But thank you for joining us.